Alright everybody, welcome back to the channel. Today we're going to be going over another first hop routing redundancy protocol. It's going to be called VRRP, or Virtual Router Redundancy Protocol. It's very similar to the way HSRP functions and the idea behind it. However, VRRP is a standard protocol, so it's not proprietary or locked down to Cisco equipment. You can run this protocol because it's a standard based at a RFC 3768 here. You can read this if you are having trouble falling asleep, I guess. But this protocol is, you can run it on Juniper equipment, you can run it on Palo equipment, you can run it on Cisco equipment, FortiGate equipment, etc. It's a standard. So that's one of the key differences over HSRP. Another key difference, as the astute observers in the audience probably have already realized, is you can have more than 2 routers as part of the VRRP group. You can have up to 16, which seems like a crazy scenario to me. I don't even know how you'd have 16 routers at your disposal to be able to do this, but regardless, you can have more than 2 routers. HSRP, you can only have an active and a standby. Here, you can have a master, a backup, and a backup. So that's what I'm going to display in this topology. We have 3 routers participating in this given VRRP group, but it's going to be similar to how HSRP functioned, right? It's not a load balancing. We can't load balance, unfortunately, across these 3 routers. We can only decide that one router is going to take ownership of this 100.7 address, and it's going to route traffic, and then if something happens to it, if its priority decrements for whatever reason, or if it becomes unresponsive, then that VRP address, IP address, is going to move over to the next router in line, and that router is going to take over all the traffic, and so on. So that's, again, it's not a load balancing protocol, it's a redundancy protocol. So with that being said, to the right here, we're going to go over the commands that we're going to do via the CLI. The scenario, the topology that I have in place here is this Linux client. It gets its DHCP address from this switch here. It's going to be a 192.168.100/24 address, which I believe he got a .4. His default gateway is going to be the VRRP IP of 100.7. And then initially, he's going to route through router 1 because router 1 has the higher priority in the group. We're going to develop a track statement here and introduce a fault into this connection here to the ISP, simulating that this router can no longer reach the internet, at which point it's going to decrement its priority, force a new election. Router 2 is going to take over this Linux box. We're not going to touch it. It's going to go from routing dynamically from router 1. It's going to now thinks it's still going to 100.7, whatever it was, but it's being routed by new hardware, a new router, back to the internet and back. So this client should retain internet connectivity, quote unquote, and it should be unaware. And then after we repair this fault or get this back online and bring up this interface again, the priority is going to come back to its original priority, and it's going to, as you can notice here, there is no preempt command like HSRP. Preempt is enabled by default in VRRP, which I think is the right move. So once router 1 retains its original priority, it's going to force a new election automatically and become the master once again, and all traffic is going to route through it again. So that's the general kind of rundown of what we're going to do. Let's get into the CLI configuration. Alright, so first we're going to get to router 1 here, which I believe I have it open. Let's get out of this. Let's open it. Let's get a better bite on it. So we're going to show IP and brief. Alright, so we need to go into 0.0.100. That is the physical sub interface. And then we're going to create the VRRP group. I'm going to just give it the arbitrary name of 7 just to be different. And then we're going to give it its shared IP address of 100.7, and then we're going to give it a priority of 109. And as you can see, it kind of looks kind of ugly because I was typing commands over the console messages, but this router has now become the master router, obviously, because it's the only one in the group. And then as long as we're on this router, we're going to create our track statement here. and we're going to say it's an INCP echo, and we're going to track in this case, the simulated ISP provider's IP address. We're not going to track the 8.8.8. We're just going to track the 1.1.1.2. So it's multiple ways to do it, but this is how I'm going to do it, just to be different. And I'm going to make the source interface this right here, the 1.1.1.1. All right, and then we're going to fill this out a little bit more. And then let's create the schedule. Life forever, start time now. And then we're going to track 1. We're going to track 1, IP, SLA 1, reachability. All right, and now we need to go back into this sub interface. Ooh, I don't think that was the right sub interface. Let me see. I think I just created a sub interface by accident. I did. Not good. All right. So we're going to go back to that sub interface and we're going to configure the track statement now. So track. So VRRP 7 track 1 decrement 3. Let's change that to decrement by 4 actually. Okay. That looks better. Alright, so let's verify our VRRP group right now. So we have our interface participating in it. It's in group 7. Its priority is 109. Preempt is enabled by default automatically. It's the master currently. What's the master? Itself. And then this is the group address right there. Okay, that's everything we want to see. So let's go over to router 2 now. Let's do a show IP and brief. And let me just show you that there's no tricks under my sleeve here. Show VRRP brief. Nothing. Okay, so let's change that. 0.0.100. 0.100. Oh, wow. It's early in the morning for me, so I'm not doing too hot here. Okay, so VRRP 7 192.168.100.7. Yep, it's like I said. Remember that thing about saying it's earlier in the morning? Okay. VRRP 7 priority. Let's give it a 108. All right. Excellent. Now, let's see what our VRRP brief. Okay, as you can see, this sub interface now is participating in VRRP, has preempt enabled. It's the given priority we gave it. It's in a backup state, but this is the group address, and the master is router 1. You know what? I don't even think I'm gonna consider. Well, okay, so yeah, let's do router 3 real quick just to show you that you can do it. But it's gonna be very similar commands here, so just stick with me just for 1 minute here while I do this. All right, so conf t. Yes, terminal interface gigabit 00.100 VRP IP 192.168.100.7. Huh. Yep. That's what happens when you try to go too fast. And then we'll say VRP 7 priority. We'll say it's 106. All right, and then we'll just verify real quick. Show VRRP brief. All right, and it's also in a backup state, as you can see. So that's all well and good. Now let's simulate the takeover for VRRP, how the re-election happens when the priority decrements. So we'll go over to our Linux client here, and we'll see what's going on with this guy. He should be pinging the constant ping to 8.8.8.8. He's not, so let's have him do that. Okay, so right now this client is pinging 8.8.8.8, simulating some resource or destination out on the internet, our topology here if you remember, and right now his traffic is going through this switch to the router, to router 1, because it's currently the VRRP master, and it's reaching the internet and it's going back. Okay. Earlier in our CLI commands we configured a track statement to ping this ISP ICMP echo, to ping this ISP address. If this goes down, if we can't reach this anymore, then that's going to mean this router is going to decrement itself. Router 2 should take over, and traffic should be routed through this router to the internet and then back to the host without having to touch the host at all. So let's prove our theory there. Let's go into interface gigabit 01 and let's shut it down. Alright, so our BGP went down, our track statement went down, and hopefully our VRRP, and so our VRRP state changed from master to backup. Now let's make sure that our hosts, so our host missed a few pings there, but it can still reach the internet again. So that means router 2 should be the master now. So let's just verify that, and it is. So even though it still has a priority of 108, that's the highest priority now because router 1 decremented himself, so it took over as the master. It has the same group address. It's routing the Linux box's traffic now. So that's all well and good. Let's turn this interface back up. We fixed it. It's the quickest fix ever for an ISP issue. So we're going to no shutdown. This router should take back over as the master, and it should route traffic back up again. So we still get a bunch of alarming messages that normally you don't want to see. But our SLA statement went from down to up. This router is now the master. Our VGP neighbor came back up, so we should be able to reach this again. We can. So that's it. Very similar, very kind of boiled down and simple topology and use case scenario there. But that's pretty much all it is for a VRRP. As usual, you can get into some of the timers and authentication and things of that nature. But for the purpose of this video, I just want to display what it is, how to use it, how to configure it. So with that being said, thanks for watching this video. Hope you learned something, and let me know in the comments if you have any questions or anything like that. All right, thank you.